I've been exploring new advancements in AI in medicine, and today I'll share the latest breakthroughs in spatial biology. When we talk about spatial biology, it's worth starting with spatial intelligence, the concept that Professor Feifei Li has really brought to the forefront. Think about it, AI has already learned how to listen and speak through natural language processing, and it can see through computer vision. But that's just the beginning. Seeing alone doesn't mean understanding. And understanding is essential if AI is going to learn and do things as we do. Human spatial intelligence goes beyond just looking at things. It's about perceiving then acting. This ability to sense and respond is what allows us to move through and interact with three-dimensional space so effortlessly. And it's also the key to pushing AI to the next level. Imagine looking at a picture by Professor Li. You see a cup of milk in the image. Don't you just feel the urge to reach out and hold it? That's your built-in spatial intelligence at work, seamlessly linking perception and action. Now Professor Feifei Li's new AI startup, World Labs, is taking on a challenge rooted in this kind of intelligence. The company has raised $230 million from some well-known investors. Radical Ventures, a Canadian firm where Feifei Li and Kai-Fu Li are scientific partners, led the round. Plus, they have Professor Geoff Hinton on board. Yes, the recent Nobel Prize winner in physics. And even NVIDIA's venture capital arm has joined in. World Lab is setting out to build software that uses images and other data to make sense of the three-dimensional world, creating what they call a big world model. Even though cancer treatments have come a long way in recent years, their effectiveness is still quite limited. It's tricky because even when patients have certain biomarkers, predicting how they will respond to treatment accurately is still a major challenge. That's because cancer is incredibly complex, and every patient has their own unique mix of genetic, protein, and cellular traits that can impact how the disease progresses and how well treatments work. So figuring out how to provide highly personalized treatment options with real insight into effectiveness has become urgent. One promising way forward is to use spatial biology, artificial intelligence, and multimodal spatial analysis to dig deeper into the hidden structures of cancer. Spatial biology is a newer field, and it's really gaining traction with a growing number of studies on spatial multi-omics. The idea is that where cells are located within a tumor is incredibly important to understanding how different parts of the tumor behave. Imagine it like a GPS system. Just as GPS coordinates let us map out locations and track movement, spatial biology techniques map out cell structures and reveal how cells interact with their surrounding environment. This approach lets scientists capture information that traditional sequencing just can't provide. With spatial intelligence, researchers can pinpoint where specific cells and molecules are in a tumor, which is essential because the way these cells are arranged has a big impact on how the tumor grows and responds to the treatments. By knowing this layout, scientists get a better sense how the cancer will act, allowing for more personalized treatment. Practically speaking, this technology enables researchers to create digital twins of patients using artificial intelligence. They analyze tumor biopsies before treatment even begins, so they can predict how well a patient will respond to treatment and whether there might be resistance. By combining multiple types of data to understand the complex environment within tumors, these models now predict patient outcomes with over 90% accuracy. Plus, they bring in revenues by offering these insights to pharmaceutical companies through specialized tools.